Welcome. In this lesson, we'll be talking about JavaScript conditions. Let's create a new web project called JavaScript conditions. The empty website. Going to quickly add a HTML page. Now a JavaScript file. Okay, in our index HTML, we're going to include the app.js. Okay. Now, before we really talk about conditions, we need to talk about comparisons. So, in JavaScript, there are multiple ways to compare values. Okay. So the first one is going to be the identity comparison, and that's done using the three equal signs. For example, if we just want to compare, in fact, I'll just run this so that I can go up here to debug Windows JavaScript console. Okay, and here we're just going to write some conditions to see exactly, what equates to true and what equates to false. So the identity condition, which is the one you should be using, is things like I can say 1, 2, 3, is that equal to 1, 2, 3? And you'll see that it equates to true. This is a string. I'm passing in a string value, putting quotes around it. 1, 2, 3 is equal to string 1, 2, 3. Okay. Now, if I want to say, how about just the number 1, 2, 3? Is that equal to 1, 2, 3? And that is also true. Now, what if I say I wanted the string 1, 2, 3? Is that equal to the number 1, 2, 3? And that's going to be false, because this is not just trying to compare the value, if you will. It's also trying to compare the type, which is typically what you want. The majority of the time, you want to explicitly know the value and not necessarily let JavaScript do some kind of a type conversion or coerce the value into a totally different type. Now, if you did want that type of functionality in certain cases, then you could do 1, 2, 3 and then use the equality comparison. Okay? And by doing that, that will come true, because you have, what it's going to do is it's going to coerce one value into the other. So it's going to take that 1, 2, 3 and say, okay, well, if they're both strings, they'll be the same. Or if they're both numbers, they would be the same. Okay? But that's not something you typically want to do, because it can introduce all kinds of problems in your code. So that is the identity. The three equal signs is identity. The two equal signs is equality. Okay? Now, you also have the not equal for there. And again, the not equal you should use is the not, which is the exclamation point, and then two equal signs. And it's the same thing. So that's looking at the identity. It's checking both the type and the value. Or if the types are not equal, then the whole thing won't be equal. And we could say 1, 2, 3 is not equal to 1, 2, 4. And that's going to be true, because 1, 2, 3 is not equal to 1, 2, 4. They're both strings. On the flip side, I can say 1, 2, 3 is not equal to 1, 2, 3. And that's going to be false, because they are equal. Okay? Now, just like we did before, I can say 1, 2, 3 is not equal to the number 1, 2, 3. And that's going to be true, because they are not equal. They're not the same type. Again, if we want to do the type coercion, then you could force it by saying 1, 2, 3 not equal to 1, 2, 3. And that's going to be false, because it's going to take them both either as strings or both as numbers and say, yeah, they are actually equal. So the identity is 3 equals, or the exclamation point, and 2 equals, and that's what you should use. The operations that do type conversion is simply double equal and then not equal. Okay. So some interesting examples to show the issues with using the equality instead of the identity version of the comparisons. Let's say we have an empty string, and we're going to compare that to 0, right? And so as we would expect, those do not equal. Okay, so we actually get the same response there. But then let's say we say, okay, well, we have just, empty string equals 0. All right, that is true. Okay, but of course, if we try to do this with the identity, it's going to say, no, that's not true. You can't. An empty string is not the same thing as 0. Okay. And the same thing is true as this way. If we do just a integer is equal to string, that comes true. But if we do the identity, we get false as we would expect, because again, the number is not the same as a string. Okay, what about we have the object false? Is that equal to the string false? Okay, and it's not. What about of course, so we get the what we would expect. Let's try this, false with a 0. Okay, so now false and the number 0 it says are the same thing. Well, if we say false with the identity, that's not the same thing. Okay, so not understanding or trying to remember what all the different rules are when you're using the double equals or the just simply the not equal, the equality operators instead of the identity operators. It's very complicated and it's hard to remember. So for the most part, the double equal and then the not equal should just be avoided, and you should use the triple equal and the not equal. Right? So those would be the operations that we should be using. Okay. Now, besides the identity and equality comparisons, we also have things like greater than or less than, or greater than or equal to, or less than or equal to. So, for example, I'd say, hey, is 500 greater than 50? Right? And of course it is. I can say, hey, is 50 greater than 50? And it's not, because they're equal. I could do the same thing with less than. Is 1 less than 50? Or is 1 greater than 50? It's not. Is 1 less than 50? It is. Is 50 greater than or equal to 50? It is, because it's actually equal to. And again, we can do the same thing here. Is 25 less than or equal to 25? Of course, it is. What if we did 50 is less than or equal to the number 50? And it is, because that's going to always do the type conversion for us. Okay? So the type conversion is going to happen here because there is no, we don't have a 50. That's not an option with the double equal. So there's really no identity column here. So you have to be careful when you're doing less than or greater than, knowing that it's going to do type conversion for you. So those are comparison operators. Now let's look at some logical operators. Let's say we say true and true. Okay? So the idea is we're passing something in and we're saying if both of these things are true, then we're going to, this condition equates to true. Okay? Versus if I say true and false, well, that's going to be false. So when you AND things together, when you AND two pieces of data together, they both have to be true in order for that combination to be true, right? So the first thing we see is true, and that equates to true. The second one, true and false, equates to false, because that will only equate to true if everything inside of the condition is true. So again, we can say true and true and true and true right? That's going to be true. But I can come in here in the very last one after all those trues and say and false. And because I have that one false, it's going to make the whole thing false because they're not all true. So the idea is if all these things are true, I want to go do something. And so this is a way we can check multiple objects at the same time. So on the flip side, we have the ors. Okay, so I can say true or true, and that's going to give me true. I could say true or false, and that will give me true. I could say false or true, and they'll also give me true. So you'll see here that in order for an AND operator to return true, everything has to be true. So anything you AND together has to be true in order to get the value of true. If you have one false in there, you need just one false, even with a bunch of trues, one false will make the whole thing false. Because it's saying this has to be true, and this, and this, and this, and this. And of course, all those are true, but then this very last one is not. And so, basically, if they're not all true, then none of it's true. Or at least you can't act on that because you're explicitly asking, are all these things true? And no, they're not all true. On the flip side, we have the or. We say, is this true or is this true? If either one of those is true, then we get back true. How about this? If either one of these are true, I want true. And sure enough, true or false is true. And of course, flip that around, false and true is also true. So if we went back to the AND operator and said false and false, right? That's going to give us false because you can't have two false. Where the whole thing's false, obviously nothing's true. And so that condition is false. Yeah? And actually the same thing's true with the or. If it's false or false, then there is no true, so the whole thing is false there. So we can see here, this is the very familiar table to all programming languages follow these rules. And this is our condition, true and true gives us true, true and false, of course, gives us false, because we're not both true. And you flip them around, you get the same thing if it's false and true. It really doesn't matter what the order you're doing the comparison in. If everything's true, you come back true. If anything is false with an AND, if anything is false, you get false. Okay? So the only time you get true back is if every single thing is true. Any other time with an AND, you're always going to get false. If there's at least one thing in there that's not true, then you always get back false. And it's kind of on the flip side with the or. As long as one thing is true, you'll get a true. So if both are true, then obviously one's true. If the first one's true, then you get true. If the second one or any other one's true, then you'll get a true. And of course, if there's no trues in there at all, then you get false. And that's how the logical conditions work. You can also use the not operator with your logicals. So the not, you don't do exclamation point and that doesn't work. You can't do that, or exclamation point or right? Can't do that. Instead, what you do is at the beginning of your operation, you put a not in front of that, right? So if not false, well, that's true, and not true is false. Okay? So I can say if true and not false, right? And that's going to get true because both of those equate to true. True equates to true, and then not false equates to true. So you can use a not along with the logical operators. You can do that with the other operators as well. You could say not 5 equals 10, right? And that's true. So we're kind of doing an equal operator, but then we're putting a not on the front of it, which gives us the true value. Right? Versus if we didn't have the not, then obviously 5 does not equal 10, so it would give us false. And that wraps up our discussion around comparison and logical operators.